Welcome to Kendall's once-in-a-lifetime Algebra Math Session. In this math session, we will talk about functional relationships, which will include graphing relationships, relation and functions, and writing functions. The examples and information will be coming from Holt McDowell's Georgia Coordinate Algebra book. First, we will work on graphing relationships. Now, graphs can be used to illustrate many different situations. For example, trends shown on a cardiograph can help a doctor see how the patient's heart is functioning. To relate a graph to a given situation, use keywords in the description. So now we are going to relate graphs to situations. Now in this example it says the air temperature was constant for several hours at the beginning of the day and then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Now, choose the graph that best represents the situation. Now, step 1, what you're supposed to do is you're supposed to read the graphs from left to right to show time passing. And in step 2, you're supposed to list the key words in order and decide which graph shows them. Now, the key words in this example are was constant, rose steadily, stayed the same, and dropped sharply. Step 3 is to pick the graph that shows all the key phrases in order. So, what do you think the answer is? You don't know? Well, I'll tell you the answer. The answer is graph B. The answer is graph B because it shows all the key words in order. It was constant, then it rose steadily, then it stayed the same, then it dropped sharply. As seen in example 1, some graphs are connected lines or curves called continuous graphs. Some graphs are only distinct points. These are called discrete graphs. Now, something that helps remind me of the difference between these two when dealing with word problems are, I think of continuous as a continuous process, and discrete is not. Now let's do another example. Simon is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. Okay, so the amount earned, which is the y-axis, increases by $2.50 for each candle Simon sells, which is the x-axis. Since Simon can only sell whole numbers of candles, the graph is 11 distinct points, as shown on the graph. This graph is discrete because they are distinct points. And another example of a continuous graph is the last example we did. Now that we've covered graphing relationships, we will now turn to relations and functions. In the last section, you saw how we were doing relationships represented by graphs. Well, I'm here to tell you, relationships can also be represented by a set of ordered pairs called a relation. So, let's do an example. This example is about a track meet. First place is worth 5 points, second place is worth 3 points, third place is worth 2 points, and fourth place is worth 1 point. The scoring system is a relation, so it can be shown as ordered pairs. The examples I have in front of you are representations of relations, like different ways you can express a relation and a relation. The first one is a table, and this is when you write all the x values under place and all the y values under points, and it just looks like a little chart. The second one is demonstrated as a graph, where you can track the scoring and use the x and y values to plot the ordered pairs. And the third example is a mapping diagram, where you write all x values under place and all y values under points, but you draw an arrow from each x value to its corresponding y value, like that. So, some key terms that are good to know are relation, which we've already went over, which is represented by a set of ordered pairs. So if there are ordered pairs, it's a relation. A function, which is a special type of relation that pairs each domain value with exactly one range value. Domain. The domain of a relation is the set of first coordinates or x values of the ordered pairs. And the last keyword is range. And the range of a relation is the set of second coordinates or y values of the ordered pairs. So in the track meet example, the domain is 1, 2, 3, and 4, and the range is 5, 3, 2, and 1. Moving on to the last session or lesson today, we're just gonna do a recap of the sections that we've learned in the book. So we've already learned graphing relationships, relations and functions, and now we're moving into writing functions.